Hello and welcome to heliosblog. My name is Helios here for another reaction video. Today, Jon Zherka has a heated flat earth debate with Michael Sartain. Part 2. Let's get into it.
The reason she's alone is because she's difficult.
Women are not accepting the bare minimum.
Women fuck men they respect.
All the women who say things like, I'm strong, independent, I don't need no man, like, y'all impress me.
Women just gaslight each other and say what they want to hear.
I'm going to go with the proofs, and I don't care what other people are saying. I'm just going to listen to what I'm saying right here. Now, what happens is with the 260,000 feet to see the curve, at 8 inches per mile squared, it starts to become inaccurate and breaks off from the measurement of a circle at 60 miles. So we're going to use a math equation here. You're 6'5", right? You're about 77 inches tall. I'm about 74 inches tall, right? So in these measurements, how much is a 1% deviation? How many inches are in a mile?
Oh, you're saying
how many inches are in a mile? It's 63,360 inches in a mile. 1% off is 630 inches. At 60 miles, you're already more than 1% off, meaning whatever variation or whatever error that there is, it's 10 times taller than you at 60 miles. That's the reason why they keep coming up with, oh, we shouldn't be able to see this when we can see this. It's two things. The 8 inches per square mile does not accurately reflect the surface of the earth, number one. And two, there's atmospheric compression, which your side agrees to, which is the reason why you see sunsets and the sun gets bigger. That's the reason why. Three, when it comes to, you know what ham radios are, right? You can bounce them off the atmosphere and come down. In your case, you bounce them off the dome.
Yeah,
come down. Okay, cool. You had Witsit talking about microwave transmissions for Ace High and NATO, and there's no way it should go 250 miles. Yes, it's called tropospheric scatter. That's how it bounces off, and you can go to 500 miles just by doing that.
Do you really believe? Do you know what your military chain of command is? Of course you know.
Yeah.
Right? Because people like Rollo would say, well, if it's a secret, how did it not leak? It's a military chain of command. Only telemetry and military would know. That's it. You don't really think the military that uses azimuthal equidistance targeting maps? Oh, you don't believe the military uses our map? You think they use Mercator?
Let me ask you a question. How did the photos from Gitmo get out?
So what Zherka's saying is that they use flat maps, therefore the earth is flat. Like, what kind of logic is that?
What is Gitmo?
Guantanamo Bay. Remember they referred to? How did that? Well, I thought the U.S. military would just keep everything a secret. How does that work?
It got out like Flat Earth, the most YouTube.
No,
that's right. That's right. That's right.
The reason
it did get.
Jon's way of arguing is just to stand up and shout. I don't even know what logical fallacy that is. Oh, appeal to emotion, manipulating an emotional response in place of valid or compelling argument. That's basically most of Zherka's argumentation style. I beat you. Earth is flat, I beat you. You know, stand up. Express your monkey dominance, you know. Alpha male. Obviously, that's not a way of arguing, right?
That's my point. No, it's literally my point.
It didn't get out. The Flat Earth is nothing but a Russian psyop in 2016. That's all.
Wow, Russians have that much power in your head?
They know that we believe them in your head because they're sitting there posting on 4chan and you believed everything they were saying.
Literally. That's hilarious. All right. Shitting time. Hit the like, hit the sub, hit all for notifications, drop me a donation like Hunter M, Adrian Altomum, and Bobby. Shoutouts to you. Thank you for subscribing to my Patreon. Buy my books at bit.ly/heliosbooks. Shoutouts to the Curry Kid, most recent purchaser of Strategist Guide to Seduction. Thank you. My Patreon can be found at patreon.com/theheliosblog. Share this video. Support me on my podcast by clicking the description box. Scroll down to support the show. All right, shitting is done. Let's continue.
Before the 2016 election. That's the only reason and we're even talking about this. There is no flat earth movement in 1975. Then none of this is happening until recently. No, there's. Okay, anyway.
Well, what about 1900s? You said Russia. In the 1900s, Russians were taught about geocentricism.
Hey, you know what?
In the 1900s, they were taught.
I mean, geocentricism is obviously not correct. And you can tell by parallax, right? Just by how things move in the sky, you can tell that the Earth is not the center of the universe, right? That's why things migrate across the sky. It's not because the Earth is the center of the universe and things spin around. Like, what? That doesn't account for the deviations that you see in the stars as time passes. All right, let's continue.
For sure. Well, what I'm curious from your standpoint, curious about from your standpoint is actually I don't want to get into this because you were saying the thing about atheists, and I won't talk about that yet. How do you explain the flight from Johannesburg to Sydney taking 12 hours?
I've heard the argument. I don't remember. I don't explain it. You can have that one.
Okay.
But
Okay. So the way that flights work on Earth is they don't actually fly straight lines. They actually fly in a curved path. They call it a curved geodesic because it sounds fancy. But the idea is the Earth is curved, so you take a curved path in order to get there faster, right? Taking a straight line path on the map would actually be slower because the Earth is curved. So a straight line on a sphere is actually a curved path.
that flight you take, if you have to make an emergency landing.
There we go. Beautiful.
Oh, no, let me make it. Yeah. All emergency landing systems in airplanes use our flat Earth.
They don't use
from your side.
They use a flat map. They don't use your flat Earth map.
Oh, no. Do they? But is there an ice wall in that?
No.
There's a reason why they use a flat map. It's because the Earth is spinning, the air on the Earth is spinning too. Because the air on the Earth is spinning too, you don't have to account for the spinning air on a spherical Earth as you're landing. Also, let me give this analogy to help you understand why the Earth looks flat from the sky. Well, at a certain height, it doesn't anymore. It looks, you can tell it's curved, but I digress. The ant walking on your leg doesn't know that it's walking on a curved leg. To the ant, it looks flat because the ant is too small to appreciate the full curvature of the thing that it's walking on. To the ant, it's walking on a flat surface with trees, right? The trees being your hair. The hair on your leg. It's the same principle on Earth. You are even smaller than an ant relative to the Earth. So to you, the Earth appears flat because it's way too large for you to appreciate its curvature. If you were bigger, you could obviously see it. But you're not, and so you can't. All right, let's continue.
No.
Is there the highest shoreline on Earth, Antarctica?
Okay, the highest shoreline on Earth is in Pakistan. One of them is in Hawaii, and the other highest shoreline on Earth is in Dover.
Apparently, Wikipedia.
I believe that Antarctica also has some of the highest shorelines in the world because the continent is raised higher than the other continents. I don't remember exactly why, but if you guys know the plate tectonics theory, you know that all of the tectonic plates, including Antarctica, were once all together. So perhaps it was raised since then, right? Or, crashing here and there between the plates, pushed up the Antarctic plate, and then they drifted away later with time. It's something like this. All right, let's continue.
Yeah, disagrees with you. Pull it up.
There are 18 shorelines higher than the one in Antarctica.
What's the high? Well, the one that when you Google it, which one pops up? It's Antarctica.
No, the one in Hawaii is actually the highest shoreline.
Lock that answer in red.
Yeah, for sure. The highest shoreline in the world is in Hawaii.
All right, let's fact check that. I can fact check it right now. Highest shoreline in world. I'm just typing it now. Sorry, I'm only typing with one hand. Following is the list of the top 10 countries with the longest coast. Oh, no, it's not. I want shoreline. No. Highest. Maybe highest is wrong. Tallest. Length of coastline. No, this is wrong. Tallest coast. Let's try tallest coast because it's not coming up when I type it. Oh, here you go. At 286 meters above sea level, the high coast of Sweden has the world's highest coastline, and the landmass continues to rise by about 8 millimeters per year. So
anyway, going back.
So that's the highest coastline. Are they talking about the longest coastline? Longest coastline is Canada. Canada's coastline is a length of 202,000 kilometers. Earth's highest coastal mountain range. Okay, let's look up this just as an aside. Earth's highest coastal mountain range moved. Okay, this is mountain range, not coast range. All right, let's continue.
Back to what you were saying before. So you explain it by how you think it's because of headwinds and tailwinds, or you just don't have an answer for that?
Yeah, I don't need, that one's like a more boring one to me. You can have it. I know what you're trying to say, but I can kind of reverse it to you. You globetards believe in your globalist model.
Okay, globetard is an ad hominem. Globalist model, that's an appeal to authority.
That Mike and Zherka can two models in a helicopter that floats 24 hours above. Well, let's say we float 10 hours above the Earth. Apparently, the Earth...
10 hours? What do you mean?
Let's say the
helicopter for 10 hours.
Here, I can't see. Put my face on screen so I can see if they can see my hand. Look at this.
Yeah.
We're in this helicopter.
Yeah.
And we let the Earth roll under us.
Yeah.
10 hours, but we land in the same spot. And you're going to... I dare you to go to Coriolis here.
Let's do it. It's
just saying that...
No. Here's what happens. And this one is obvious. The helicopter hovers. Okay. So that means that relative to the Earth, it doesn't move. But that is not to say that something else doesn't move relative to the Earth. What does move? What moves is the atmosphere, because the Earth spins, pulling the atmosphere with it, and pulling the helicopter standing still in that moving atmosphere. It's like, how would I explain it? Imagine you're a swimmer, okay? You're treading water in the ocean, but there's a riptide. So you are standing still, right? Because you're treading water in place. But there's a current underneath you of water that's pulling you out towards open water. So you are not moving, but the medium you're in, the water, is moving. So you get pulled out, you get pulled out. Now, if you're in the air, the Earth is spinning. Therefore, the land on the Earth is spinning. But because the Earth is spinning, the air on the Earth is also spinning. And because the air and the Earth are spinning at the same speed, more or less, unless there's, an air current, in which case that obviously this doesn't apply. It would be more extreme. The difference would be more extreme. If you're in the jet stream, for example, right? But let's say you're not. Then the helicopter would land in the same place. Because the Earth and the air is moving together, pulling the helicopter that to you in the helicopter, you think you're standing still, but you're actually not, because the air is moving. And you can't see it because air is invisible. But if you colored the air, you would see that it's clearly moving in a direction, right? And it would be moving the same way that the Earth is moving. Like they do in those fancy labs where they test the cars, like they color the air and then you can see that it's rushing, right? That it's not just standing still. It's the same if you're treading water in the ocean. You can't see the water moving. I mean, you can see it moving on the surface, but you can't see it moving under the surface. It looks still, but it's not still. It's the same with air on the Earth, right? And actually, the water on the Earth moving is also in part because of the Earth's rotation. It not only, right? We get the moon's orbit as well that affects how the water moves and more. We get temperature changes and and so on. But temperature differentials. Okay, let's continue.
The atmosphere is moving too.
It's not Coriolis.
No, bite the bullet. Say the atmosphere is moving too.
So we're gonna go back to the
I want
the atmosphere is moving too.
The original formation of the Earth, the proto-Earth, there was no atmosphere on it. Once the atmosphere comes, the atmosphere is subject to the same angular momentum as the Earth that is spinning.
Yeah.
So meaning what you're saying before is that the Earth.
Let's explain this Coriolis effect because I'm curious. The Coriolis effect describes a pattern of deflection taken by objects not firmly connected to the ground as they travel long distances. I don't understand. Okay. The Coriolis effect is responsible for many large-scale weather patterns. The key to the Coriolis effect lies in the Earth's rotation. Specifically, Earth rotates faster at the equator than it does at the poles, of course, because the Earth is oblong. It's not a sphere. It's not a perfect sphere. Earth is wider at the equator, so to make a rotation... Okay, let's pretend you're standing at the equator and you want to throw a ball to your friend in North America. If you throw the ball in a straight line, it would appear to land to the right of your friend because he's moving slower and has not caught up. Okay. The deflection is the Coriolis effect. Fluids traveling across large areas such as air currents are like the path of the ball. They appear to bend to the right in the northern hemisphere. The Coriolis effect behaves the opposite way in the southern hemisphere, where currents appear to bend to the left. The impact of the Coriolis effect is dependent on velocity. The velocity of Earth and the velocity of the object or fluid being deflected. The impact is most significant with high speeds or long distances. And this affects the creation of trade winds and stuff like that. Okay, there you go.
The atmosphere should be going.
I read that from National Geographic, by the way.
Along with the Earth, because what you're doing is you're
what you believe.
You're presupposing that there's something dragging the atmosphere, but there's nothing up there for.
No, you're saying. No, stop. You're saying the hell is being dragged.
I'm not saying anything's.
Then why are you landing in the same spot?
Relative to that spot, it's not being dragged anywhere.
That's
relative to the Earth's motion.
It's not going anywhere.
No, it's not.
What? No. Zherka doesn't understand. He's actually not understanding the scientific argument.
So the point is, what you're trying to say is that the atmosphere, if the Earth is spinning, should be dragged behind the Earth, but it shouldn't, because it contains the same angular momentum as the Earth. I'll give you an example. If a woman is pregnant and she gives birth to a child, the child doesn't fly in that direction at 1,100 miles an hour.
That's right.
The child has the same angular momentum as its mother when it is birthed. Just like the atmosphere has the same angular momentum as the Earth when it first emerged from the Earth.
So same with an airplane?
No, the airplane, whatever.
So how the hell does a plane get from point A to point B?
What do you mean how? The Earth is spinning, the atmosphere is spinning, but an external force is being applied to push the plane where the pilot wants it to go. An external force is being applied. That's the jets.
Because the atmosphere has the same angular momentum as the Earth. See, you're trying. So the whole.
Your argument is when you're in a car, you don't feel the speed, right?
What? You don't actually. You don't feel the speed. You feel the acceleration. You feel the change in speed. But if you're going at a constant speed, you don't feel it, except by relativity. So here's a really good example, actually. So you're driving on the highway, okay? You and your friend, and just for fun, both of you go at exactly the same speed, and you go parallel to each other. If you look at your friend, it looks like his car is standing still, and it looks like your car is standing still, if you're looking at each other. Because relative to each other, you are standing still. But if you look at the scenery out the side, the scenery appears to be moving. And that's because relative to the scenery, it is moving, right? Now, it gets more interesting. Now, if you look at the opposite lane, where those guys are coming, they appear to be coming much faster than the guys on your side of the highway. So, the car to your right, who's going a little bit faster than you, he only seems to be going a little bit faster. But those guys going the other direction, they're going way faster. And the reason is because you're going in opposite directions, so it appears to be double speed. That's because the light isn't being sped up. Light travels at the same speed. But relative to the other car, basically, you're helping yourself to see the other car move faster. I don't know if that makes sense. Because it's moving in the opposite direction as you, so you're both headed for the same place twice as fast, for the same point in space, twice as fast. Because it's helping you get there effectively. That's why head-on collisions are more dangerous than rear end, especially going at high speeds. So let's say you and a car in front of you are both going 100 kilometers an hour on the highway, okay? Or whatever, 120 or 140, it doesn't really matter. If you tap the car in front of you and you're both going perfectly straight, you'll actually feel nothing and no accident will occur. It'll just feel like a little bump, because relative to each other, you're going 5 kilometers an hour, 2 kilometers an hour, whatever the mile difference is between you two. Whereas if you reverse the situation and both of you are going 120 kilometers an hour, when you hit that point, both of you are adding to the speed with which you get to that point. So by relativity, you're going to hit it twice as hard, right? So Zherka's just not understanding the scientific principle here.
No, you feel the...
I hope I explained relativity okay. You guys tell me in the comments. Maybe I was inaccurate in my explanation. You guys can do better. I did my best.
acceleration. Once you
but
set
not
at
the
a certain
speed, right?
Once you set at a certain
You don't
speed,
feel
say
the
this.
speed.
Of course,
Right, you don't
the same
feel
way.
it.
Do you?
Hold on.
You disagree with that argument?
Hold on, I agree, but
Okay.
you're not in a car. You're on the roof. Are you going?
Okay, there's more. If you are standing still and you see somebody suddenly start moving, you'll feel like you're moving. That can happen as well. Again, that's because of relativity. But if you're on the roof of the car, why do you fall on your bum? Well, the reason you fall on your bum is because although you're going the same speed as the car by standing on the roof, the air is not. There's a wall of air there, and you slam into that wall of air, which is still, because the air, well, it's not still, it's going at the, you get what I'm saying. Okay, anyway, relative to you. So the wall of air is still, so you hit it, it knocks you over. That's what's actually happening. You're pushing into the air that's not going any speed relative to you. That's the idea.
You're gonna feel motion.
No, if you're
That's the plus of the earth.
No, you're going to feel the acceleration as you decelerate by slamming into a wall of air.
You lost.
if you are in
Yeah, you lost. You lost. Appeal to emotion.
if you are but no, again, when you're in a car, the atmosphere is moving against you. That's not what's happening.
Are you
here.
feeling motion on the roof of the car, Mike?
Yes, you are. You're feeling the deceleration of slamming into a wall of air.
Or is gravity just helping you?
One more time. If the angular momentum of the atmosphere is the same angular momentum of the Earth, then the atmosphere is going to move with the Earth.
Cute non-answer.
It is the answer.
It's not a non-answer.
Did you feel motion on the roof of a car?
No, because you know if you were
Try this. Why don't we try this?
If you were on the roof of a car, you wouldn't feel motion, except what you would feel is the wind in your face. You wouldn't feel motion.
Really? So if I'm driving,
Actually, what you would feel is going from 0 to starting to move, right? And in which case you would have to adjust because you were an object that was at rest and now you're at motion. So this is inertia, right? And then as you're going faster and faster, now you feel the still air slamming into you, pushing you backwards.
and I just do this, you're not gonna feel that.
But you would feel it inside.
Well, if you turn the wheel sideways, now you're adding direction, right? But here's the thing. You're on the roof and there's low friction, right? So when you add this change of direction, what's going to happen is you're going to slide backwards because there's still a backwards force on you, the air that's pushing you, and you're going to slide off the car. But you'll slide in a straight line, actually. You won't slide on a curved path. Anyway.
the car also. You feel it inside the car also. Oh, whoops, boom. Yes, you would feel it
point
inside the
is
car and outside the car because inertia is conserved. Angular momentum is conserved. The problem is what the flat earthers do, and I've seen like round earthers trying to have this debate, is they forget this point. The angular momentum is conserved in the entire planet, and everything that since its inception is there. Again,
Wait, at what point do you magically go high up enough that you're into outer space? Do you what?
375,000.
There is a point. Technically speaking, what is outer space? Outer space is when there's no more atmosphere. So you can just Google it. When is there no more atmosphere? That's when you're in space. Though you will still be affected by Earth's gravity, right? If you want to talk about the point where you're not really being affected by Earth's gravity, you have to go pretty far, right?
Feet. Now here's my question for you. Ready? Do you remember those jet streams that Whitsitt was talking about was blowing the things back and forth?
Debate?
No, it was your debate that you did with him. My question is, GPS, you're going to tell me is not satellites. That's fine. We'll give you that. You think it's a bunch of weather balloons, correct?
No.
What do you think? Where's GPS come from? And by the way, GPS does work in the Pacific.
I didn't say that
the north
ever in my life. I don't know much about GPS. I always talk about Why?
Right, but where's GPS?
I said Wi-Fi.
I flew
No, I got to ask you because you're going to talk.
I flew over Pacific.
You're attacking an argument that's not even mine.
But it is a flat Earth argument that they have to answer.
All right, but it's not mine because if you said you got a list of my arguments. You said you got a list of mine arguments.
He's attacking me for arguments I didn't make. I have said nothing about NASA, nothing about Mars, and then I'm doing the same thing here.
No. Look, I know you said you wrote down my positions.
Yes.
That's a Wi-Fi, not a GPS. 97% of Earth Wi-Fi is done through triangulation, grid towers. That's why when you leave to go to the mountains, you lose connection.
No, but your GPS still works.
Okay, are there satellites? How do you not have satellite coverage in the mountains?
But you do. You don't have satellite.
I lose it on here. I lose it.
One more time. Cell signals are UHF. The GPS uses a chip that triangulates your position between 4 different satellites. That is not UHF.
Do you believe that Wi-Fi is done through? Do you believe Wi-Fi is done through the grid and underground sea cables or not?
No.
What?
Actually,
is 97% of it?
There's a modem in here, a router in here.
You don't buy into this?
The modem is beaming UHF signals into my phone because I've got the password for this Wi-Fi.
I didn't ask that. I said, do you believe that 97% of Earth Wi-Fi has nothing to do with anything in space?
Okay, so I don't understand. What's wrong with that? Or are you saying I really don't actually know how Wi-Fi works? Like I could look into it. Here, I'll just Google it. How does Wi-Fi work? Transmits data using radio waves. A device's wireless adapter converts data into a radio signal that sends it out via an antenna. This process works both ways. The router takes data from the internet, converts it to a radio signal, and sends it back to the device to be decoded. So, radio waves are being changed into zeros and ones. That's effectively what's happening. So the language of computers and computer chips and stuff like that is binary. So you have to have some kind of translator. So you have like the radio wave sends information, which is then transferred into zeros and ones, which then does whatever, and then as they're being sent out, they're converted back into radio waves sent out, and so on. And there's a converter in your phone. Okay, I get it. Okay, so that doesn't require necessarily satellites, though you could have satellites that do it. I fail to see what's wrong here. I mean, if Wi-Fi transmits data using radio waves, you could bounce the radio waves off the atmosphere. What's wrong with that? Okay, anyway. Cool. Let's end the video there. Hit the like, hit the sub, hit all for notifications. Drop me a donation like Hunter M, Adrian L. Tomem, and Bobby. Shoutouts to him. Most recent Patreon subscriber, thank you. Go buy my books at bit.ly/heliosbooks. Shoutouts to Curry Kid, most recent purchaser of Strategist Guide to Seduction. Thank you. My Patreon can be found at patreon.com/theheliosblog. You can support me on the podcast by clicking the description link, scrolling down to support the show. Share this video. Thank you so much for listening, especially if you listen to the end. I really do appreciate it. Take care of yourselves, and I'll see you next time.